Welcome, dear friend, to this quiet space, a gentle haven where thoughts can drift and worries can softly fade. Take a moment, if you will, to truly settle in. Feel the quietness around you, perhaps the soft hum of the world beyond, or simply the gentle rhythm of your own breath. Where are you right now in this vast spinning world? What time is it in the grand sweep of moments that make up our lives? There's no need for a quick answer, no pressure to find anything at all. Just an invitation to simply be. This is a place for your mind to wander, to explore, to simply exist without the rush of the everyday. We're not here to learn facts for a test, or to seek medical advice, or to find quick fixes for anything at all. No, this is a journey for the soul, a quiet contemplation of the grandest ideas, a gentle lullaby woven from the fabric of the cosmos itself. Let your curiosity be a soft light, guiding you through the vastness, and allow yourself to simply drift. Tonight, or whenever you find yourself here, we begin a journey not across distant lands, but through the very essence of existence. We will whisper about time, about the vast emptiness that isn't quite empty, about the very beginning of everything, and perhaps about worlds beyond our imagining. These are not concepts to be grasped tightly, but rather to be felt, to be pondered, to be allowed to wash over you like a gentle tide. There is beauty in the not knowing, a profound peace in the questions themselves. So, breathe in, breathe out, and let us begin this quiet exploration together. Perhaps, as you settle deeper into your space, a thought might gently surface, a question that has always lingered at the edges of your awareness. What about the very beginning, the start of everything we know, everything we see, everything we are? It's a concept so immense, so profound, that it often feels too big for our human minds to truly hold. Yet, we try, don't we? We reach out, with our minds and our instruments, to touch the distant echoes of that first grand moment. You have surely heard whispers of the Big Bang, that monumental idea suggesting our universe began from an incredibly hot, incredibly dense point, expanding outwards ever since. Imagine, if you can, a single infinitesimal speck containing all the energy, all the matter, all the potential of everything that would ever be. It's a thought that defies our everyday experience, where things are always finite, always contained. But in the realm of the very, very beginning, our familiar rules seem to bend, to stretch, to sometimes even vanish. Think of it not as an explosion in space, but as the explosion of space itself. Before that moment, there was no outside for it to expand into, no pre-existing void waiting to be filled. Instead, space and time, along with it, began at that instant. It's a subtle but crucial distinction, one that invites us to let go of our usual ways of thinking about beginnings and endings. It's like trying to imagine a journey without a road, or a story without a single word. It's challenging, yes, but also wonderfully liberating, isn't it? In those first fleeting moments, the universe was a place of unimaginable energy, a swirling, seething soup of fundamental particles. It was too hot, too dense, for anything we would recognize today to exist. No stars, no galaxies, no planets, certainly no gentle breezes or quiet moments like this one, just pure, raw potential, expanding and cooling at an astonishing rate. It's a dance of creation, a cosmic ballet of forces and particles, all unfolding at speeds that defy our comprehension. As the universe stretched, it cooled. And as it cooled, things began to shift, to settle, to form. Imagine a mist slowly clearing, revealing shapes and forms that were always there. just hidden by the density. Particles that were once indistinguishable began to coalesce, to find their partners, to form the very first building blocks of matter. It was a time of profound transformation, a journey from pure energy to the earliest whispers of structure. This idea, this Big Bang, is not just a wild guess. It's supported by echoes, by faint whispers that still resonate through the cosmos. One of the most compelling of these is the cosmic microwave background, or CMB. Think of it as the afterglow, the faint warmth left over from that initial fiery beginning. It's like standing in a vast, ancient hall and feeling the residual heat from a fire that burned billions of years ago. This gentle hum of radiation, detected coming from every direction in the sky, is a direct snapshot of the universe when it was just a baby, only about 380,000 years old. Before that, it was too hot and dense for light to travel freely, like a thick fog. But as it cooled, the fog lifted, and this ancient light was set free, traveling across the vastness to reach our instruments today. It's an astonishing thought, isn't it, that we can, in a sense, look back in time, not just to the distant stars, but to the very infancy of the universe itself. This faint glow, this gentle whisper from the past, tells us a story of expansion, of cooling, of the slow unfolding of everything. It's a story told not in words, but in the very fabric of space and time. And as you listen to this whisper, perhaps you can feel a connection, a resonance with that ancient beginning, a sense of belonging to something far, far grander than our everyday lives. But even with the Big Bang, our minds, ever curious, inevitably ask what came before. If time itself began at that moment, then before loses its usual meaning, doesn't it? It's like asking what's north of the North Pole. The question itself pushes the boundaries of our conventional understanding, yet this doesn't stop us from wondering, from gently probing the edges of the unknown. This is where science, in its most poetic form, begins to offer possibilities, not certainties. One such idea is cosmic inflation. Imagine, if you will, that in the tiniest fraction of a second after the Big Bang, the universe underwent an incredibly rapid, exponential expansion. It wasn't just expanding, it was inflating, like a balloon being blown up at an unimaginable speed. This brief, powerful burst of growth could explain why our universe appears so flat and uniform on large scales, and why the cosmic microwave background is so remarkably smooth. It's like taking a tiny, wrinkled piece of fabric and stretching it out so quickly that all the wrinkles disappear, leaving a vast, flat expanse. This inflationary period is a beautiful, almost ethereal concept. It suggests that the universe we see today, with its billions of galaxies and countless stars, is just a tiny, observable patch of something much, much larger that was stretched out in an instant. It's a theory that helps to smooth out some of the initial puzzles of the Big Bang, offering a gentle explanation for the grand uniformity we observe. But it also opens up new avenues of wonder, doesn't it? If inflation was so rapid, so powerful, what might that imply about the very nature of space and time? And then, there are even more profound questions, gently rising like mist from a still lake. What caused the Big Bang? Was it a unique event, or is it part of a larger, ongoing process? Here, our scientific understanding becomes more speculative, more like a quiet dream. Some theories suggest that our universe might be just one bubble in a vast, ever-inflating multiverse, a cosmic foam where new universes are constantly bubbling into existence. Each bubble, a new beginning, a new set of physical laws, a new unfolding of possibility. Imagine this an infinite ocean of potential, where Big Bangs are not singular events, but rather continuous occurrences, like countless tiny sparks igniting in a boundless darkness. Each spark, a universe. Each universe, a unique story. It's a concept that can feel both overwhelming and strangely comforting. Overwhelming in its scale, comforting in the idea that creation is not a finite act, but an eternal dance. Another gentle whisper from the realm of theoretical physics is loop quantum gravity. This approach tries to reconcile gravity, the force that shapes galaxies and holds us to the Earth, with the strange quantum world of the very small. In this view, space and time are not smooth and continuous, but rather made up of tiny, discrete loops, like a finely woven fabric. If you zoom in close enough, the fabric of reality reveals its stitches, its individual threads. What does this mean for the Big Bang? It suggests that perhaps there was no true singularity, no infinitely dense point. Instead, at the moment we call the Big Bang, the universe might have bounced from a previous state of contraction. Imagine a cosmic accordion, expanding and contracting, breathing in and out through eons. This big bounce theory offers a cyclical view of the universe, where beginnings are also endings, and endings are also new beginnings. It's a gentle rhythm, a cosmic breath, echoing through eternity. It removes the need for a singular, abrupt start, replacing it with a continuous, flowing process. This idea of a universe that breathes, that expands and contracts, can be a deeply calming thought. It suggests a natural cycle, a cosmic ebb and flow, rather than a sudden, inexplicable burst. It's like watching the waves on an ocean shore, constantly arriving and receding, each wave a new moment, yet part of an endless ancient rhythm. And in that rhythm, perhaps, we can find a sense of peace, a quiet acceptance of the grand, unfolding mystery. Then there's the elegant, almost poetic idea from Stephen Hawking and James Hartle, known as the no-boundary proposal. This theory suggests that the universe has no boundary in space or time, much like the surface of a sphere has no beginning or end. If you walk on the surface of the Earth, you never encounter an edge. Similarly, in this proposal, the universe, when traced back to its earliest moments, doesn't shrink to an infinitely dense point, but rather smooths out, becoming more like a rounded cap. It's a way of imagining the universe's beginning without a before in the traditional sense. It suggests that time, as we understand it, might have behaved differently in the very early universe, perhaps even becoming indistinguishable from space. It's a profound thought, isn't it? That the very fabric of our reality, the dimensions we inhabit, might merge and shift in ways we can barely comprehend at the deepest levels of existence. This proposal offers a universe that simply is, without a sharp, jarring start, but rather a gentle, continuous emergence. It invites us to let go of the need for a distinct point of origin and embrace a universe that is, in a sense, self-contained and eternally unfolding. As we gently explore these vast ideas, these whispers of how everything began, it's important to remember that these are just theories, possibilities, beautiful intellectual constructs that help us make sense of the universe's profound mysteries. We don't know for sure. We may never know with absolute certainty, and that, in itself, is a beautiful thing. It leaves room for wonder, for continued exploration, for the quiet satisfaction of simply asking the questions. The universe, in its earliest moments, was a place of such profound simplicity, yet also of such immense complexity. It was a canvas waiting for its first brushstrokes, a melody waiting for its first note, and from that initial, incredible potential, everything we see and experience today, slowly, patiently, beautifully unfolded. The stars, the galaxies, the dust clouds, the planets, and eventually, life itself, all emerged from that ancient cosmic seed. Think of the journey from that initial hot, dense state to the cool, vast expanse we inhabit now. It's a story of incredible transformations, of fundamental forces shaping matter, of gravity weaving cosmic tapestries of stars and galaxies. It's a story that continues to unfold, right here, right now, as the universe continues its gentle, relentless expansion. And as you consider this grand narrative, this cosmic epic of beginnings, perhaps you can feel your own sense of scale shifting. Our lives, our moments, our breaths, are tiny fragments in this immense story. Yet, they are also intimately connected to it. The atoms that make up your body, the very air you breathe, the light that allows you to see, all trace their origins back to those earliest moments, to the heart of stars, to the grand cosmic dance. You are, in a very real sense, stardust, a living, breathing testament to the universe's incredible journey. Let this thought settle gently within you. You are part of something ancient, something vast, something truly magnificent. There is no need to rush, no need to fully grasp every detail. Just allow the ideas to wash over you like the soft waves of a distant ocean. Let them soothe your mind, quiet your thoughts, and perhaps lead you towards a deeper sense of peace. The questions themselves are the companions on this journey, and the wonder is the destination. We have only just begun to whisper about the universe's origins, and already the possibilities stretch out before us like an endless, star-strewn sky. In the quiet contemplation of these grand ideas, we find not just knowledge, but a profound connection to the cosmos, a sense of belonging to something truly eternal. So, as you drift deeper into this tranquil space, carry with you the gentle hum of the cosmic microwave background, the whisper of inflation, the quiet rhythm of a bouncing universe, and the elegant simplicity of a no-boundary beginning. All are possibilities, all are beautiful, and all invite us to simply wonder. The journey continues, not with a sudden jolt, but with a gentle, continuous flow, much like time itself. And as we move forward, we will explore more of these profound mysteries, allowing them to unfold around us like a soft, comforting blanket. For now, simply rest in the quiet beauty of these cosmic beginnings, knowing that you are a part of it all. As we let the grand, ancient story of cosmic beginnings gently settle within us, a new layer of wonder begins to unfold, subtly shifting our focus from the vast outward stretches of space to the more intimate, yet equally profound dimension that governs every moment of our existence. This dimension, so familiar and yet so enigmatic, is time. You feel it, don't you? This ceaseless flow, this relentless progression from one moment to the next. It's woven into the very fabric of our being, a constant companion from our first breath to our last. We mark its passage with ticks of clocks, with the turning of seasons, with the quiet growth of trees and the gentle aging of our own faces. But what is time? Really, is it a river, flowing ever onward? Is it a canvas upon which events are painted? Or is it something far more subtle, more intertwined with reality than we can possibly imagine? Close your eyes for a moment, if you feel comfortable doing so, and simply try to observe time as it passes, not the clock time, not the deadlines or appointments, but the pure, unadorned experience of a moment becoming the past, and a new moment arriving as the present. It's elusive. Isn't it like trying to hold water in your hands? The present is always slipping away, always transforming into memory, and the future is always approaching, a realm of pure potential waiting to become real. This feeling, this inherent understanding of time's direction, is often called the arrow of time. Why does time always seem to move forward? Why don't we see shattered teacups reassembling themselves, or ripples in a pond contracting back to a dropped stone? This profound mystery is often linked to the concept of entropy, a fundamental principle in physics. Imagine a beautifully organized deck of cards. As you shuffle them, they invariably become more disordered. You'd never expect a randomly shuffled deck to perfectly reorganize itself. Would you? Entropy suggests that systems naturally tend towards greater disorder, towards a more uniform, less structured state. In the vast theater of the universe, this means that energy spreads out, information gets scrambled, and differences tend to smooth themselves out. The Big Bang, as we gently explored, started from a highly ordered, very dense state. As the universe expands and evolves, it is, in a sense, constantly shuffling its cards, moving towards a state of greater disorder. This cosmic tendency towards increasing entropy might be the deepest reason why time has a direction, why it always seems to flow from the past to the future, never the other way around. It's a gentle, relentless march towards equilibrium, a cosmic settling. But our experience of time isn't just about entropy. There's also psychological time, the way our minds perceive its passage. Have you ever noticed how time seems to stretch when you are fully immersed in a moment of joy, or when you are lost in thought, utterly captivated by a beautiful piece of music, and yet it can speed by in a blur when you are bored, or when a cherished holiday comes to an end? This elasticity of perceived time is a testament to the intricate dance between our inner world and the outer reality. It reminds us that time is not just an objective, ticking clock, but also a deeply personal, subjective experience. Sometimes, when we are very still, very present, moments can feel incredibly long, rich with detail and sensation. In other instances, a whole year can feel like a fleeting dream. This gentle elasticity, this subtle bending of time within our own minds, whispers of a deeper truth that our relationship with time is as fluid and unique as we are. Then we encounter the revolutionary ideas of Albert Einstein, which transformed our understanding of time from a universal, unchanging backdrop to something far more dynamic and interconnected. His theories of relativity tell us that time is not absolute. It's not a separate entity that flows uniformly for everyone, everywhere. Instead, time is woven together with space to form a four-dimensional fabric called space-time. Imagine a vast, soft blanket stretched taut. This is space-time. Now, imagine placing a heavy bowling ball in the middle. The blanket bends. It curves around the ball. This bending, this curving, is what we perceive as gravity. And similarly, massive objects and even speed can warp the fabric of space-time, affecting the passage of time itself. This is the remarkable phenomenon known as time dilation. Think of it like this: if you were to travel very, very fast, perhaps aboard a spaceship moving close to the speed of light, time for you would pass more slowly than for someone remaining on Earth. You would age less, experience fewer moments, while years might pass for those you left behind. It's not just a trick of perception, it's a real, measurable effect. Astronauts on the International Space Station, moving at incredible speeds around Earth, actually experience time slightly slower than people on the ground, though the difference is minuscule in our everyday lives. And gravity, too, in its silent, powerful way, bends time near a massive object, like a black hole. Where gravity is incredibly strong, time would slow down dramatically. Imagine approaching a black hole. From your perspective, time might feel normal, But to an observer far away, watching you, your movements would appear to slow, to stretch, perhaps even to freeze entirely as you got closer to the event horizon, that point of no return. It's a dizzying thought, a gentle reminder that our intuitive understanding of time is often just a simplified version of a much grander, more fluid reality. This means that time is not merely a stage upon which the universe plays out its drama. It is an active participant, bending and stretching and curving, intimately connected to the very presence of matter and energy. It's a dance between objects and the dimensions themselves, a ballet of space and time. This intertwining nature offers a profound sense of unity, suggesting that everything is connected, from the smallest particle to the largest galaxy, all existing within this mutable, dynamic fabric. But when we delve deeper into the realm of the very, very small, where the strange rules of quantum mechanics hold sway, time becomes even more mysterious. In the quantum world, particles don't just exist in one place. They can exist in many places at once. Their properties described by probabilities rather than certainties. And when we try to apply our concept of time to these tiny, elusive entities, it becomes incredibly difficult. Some theories suggest that time at the most fundamental level might not be a smooth, continuous flow at all, but rather a series of tiny, discrete steps, like individual frames in a cosmic film. This idea, sometimes whispered about in the context of theories like loop quantum gravity that we briefly touched upon in the previous chapter, proposes that space-time itself might be quantized, broken down into indivisible units. If this is true, then perhaps there is a smallest unit of time, a tiny fundamental tick that cannot be further divided. It's a thought that challenges our everyday perception of time as endlessly divisible, inviting us to imagine a universe where even time has a grainy, pixelated texture at its deepest level. And if time is indeed pixelated, if it moves in tiny, discrete jumps, what does that imply about the nature of change, of motion, of existence itself? It's a concept that can feel both unsettling and strangely beautiful, like discovering that a seemingly smooth painting is actually made up of countless tiny, individual brushstrokes. It invites us to look closer, to ponder the underlying structure of reality, even in the abstract realm of time. This leads us to an even more fundamental question, one that has occupied philosophers and scientists for centuries. Do the past, present, and future truly exist, or is only the present moment real, with the past fading into non-existence and the future yet to come into being? Our intuitive sense tells us that the past is gone, locked away in memory, and the future is not yet here. Only the now is real. This is often called the presentism view. It's comforting in its simplicity, aligning with our direct experience of life unfolding moment by moment. But the theories of relativity gently challenge this. If time can stretch and shrink, if observers in different frames of reference can disagree on which events are simultaneous, then perhaps the past, present, and future are not so neatly separated. This perspective, sometimes called eternalism or the block universe theory, suggests that all moments in time, past, present, and future, exist simultaneously, like points on a four-dimensional tapestry. Imagine this tapestry, vast and unrolling before you. Every event, every whisper, every star's light, every gentle breath you take is already woven into its fabric. We, as conscious beings, simply experience ourselves moving along a particular thread, perceiving one moment after another. It's a view that can feel deterministic, perhaps even a little unsettling, but it also carries a profound sense of permanence. If all moments exist, then nothing is truly lost. The gentle touch of a loved one from yesterday, the quiet beauty of a sunset from years ago, the hopeful dreams of tomorrow, they are all, in a sense, eternally present within the cosmic fabric. This philosophical contemplation of time's existence can be incredibly calming. If all moments are, then perhaps the anxieties of the past and the uncertainties of the future hold less sway. We can rest in the knowledge that everything simply is, in its own unique place within the grand tapestry. It invites a surrender, a letting go of the constant striving to control time, and an embracing of its immutable, mysterious nature. And what about the deep connection between time and consciousness? Our minds are uniquely capable of remembering the past, imagining the future, and experiencing the present. Is time something that arises from our consciousness, or is our consciousness merely a mechanism for perceiving an external pre-existing flow? These are questions that gently weave together the scientific and the spiritual, the objective and the subjective. When you are deeply present, fully absorbed in a quiet moment, time seems to melt away. The distinction between past and future blurs, and all that remains is the profound stillness of the now. In these moments of pure presence, we touch upon a timelessness, a sense of being outside the usual confines of chronological progression. It's a hint, perhaps, that time, in its deepest essence, might be something more fundamental, something that permeates our very awareness. So, as we explore these myriad facets of time, its arrow, its relativity, its quantum whispers, and its philosophical existence, remember that we are simply wandering through a landscape of profound mystery. We do not have all the answers. Indeed, perhaps the very concept of a definitive answer to what is time is itself an illusion. Time might be something we experience, something we measure, something we describe, but never fully grasp. And that is perfectly all right. In fact, it is beautiful. The uncertainty, the lingering questions, the open-ended nature of this fundamental dimension all invite us to remain curious, to remain humble, and to simply allow ourselves to be carried along by its gentle, ceaseless current. Let the idea of time, in all its complexity and simplicity, wash over you. Feel its presence in your breath, in the quiet beating of your heart, in the subtle shifts of light outside your window. Time is a gift, a canvas for experience, a dimension in which consciousness can unfold. Whether it's a flowing river, a pixelated film, or an eternal tapestry, it holds the stories of galaxies, the birth of stars, the quiet evolution of planets, and the fleeting beauty of every single life. You are moving through it, with it, and as part of it. There is no escape, only a deeper, calmer immersion. Let the whispers of time lull your thoughts, allowing them to soften, to gently drift away. You are safe within this unfolding moment, carried by the universe's ancient rhythm. There's nothing to do, nowhere to be, but here, now, in this vast, mysterious flow. As the gentle currents of time softly carry us forward, allowing us to float through its profound mysteries, our attention might now be drawn to another fundamental aspect of our universe, one that seems, at first glance, to be the very antithesis of fullness and activity. We turn our gaze now, gently, towards empty space, or what we often call the vacuum. What comes to mind when you hear the word vacuum? Perhaps a vast, silent void, a desolate expanse utterly devoid of matter, light, or sound, a profound nothingness, stretched out between the stars and galaxies, cool and still. For centuries, this was largely how we imagined it, a passive backdrop, an empty stage upon which the cosmic drama unfolds. It seemed to be the ultimate quietude, the deepest stillness, a place where truly nothing was happening. But science, in its patient, curious way, has a remarkable habit of revealing hidden depths, of whispering secrets where we once perceived only silence, and the vacuum, this seemingly empty space, is perhaps one of the universe's most astonishing revelations. It turns out that this profound nothingness is, in fact, teeming with unseen activity, a vibrant, seething realm far from inert. Imagine, if you will, not a void, but a vast, invisible ocean, not an ocean of water or air, but an ocean of pure energy, simmering and bubbling with a silent, unseen life. This is the modern understanding of the quantum vacuum. It's not empty at all. Instead, it's a dynamic, fluctuating field, pregnant with potential, constantly shifting and stirring at the most fundamental level of reality. Think of it like this: if you could zoom in, closer and closer, beyond atoms, beyond particles, beyond even the very fabric of space-time that we spoke of, you would find that the empty space is not truly blank. It's more like a boiling pot, not with water, but with invisible, fleeting ripples of energy. Or perhaps imagine a vast, taut trampoline, stretched perfectly smooth. Even without anyone jumping on it, the trampoline is never entirely still. It vibrates with tiny, imperceptible tremors, a ceaseless, restless energy. This unseen vibration, this inherent restlessness, is the very nature of the quantum vacuum. These tiny tremors, these silent ripples in the fabric of space, manifest themselves as what we call virtual particles. These are not like the everyday particles we know, electrons or photons, that have a stable, measurable existence. No, virtual particles are truly ephemeral, ghost-like entities that flicker into existence from the vacuum and vanish back into it in an impossibly short span of time before they can ever be directly observed. They are born from pure energy, exist for a fleeting, immeasurable instant, and then return to the energy from which they came, like tiny breaths on a cold window pane, appearing and disappearing in the blink of an eye. It's a bizarre and beautiful idea, isn't it? That even in the deepest, darkest reaches of space, where no matter or light is present, there is this ceaseless dance of creation and annihilation. It means that nothing is not really nothing. It is a constant, subtle ballet of potentiality and manifestation, a continuous murmur of existence at the very heart of the void. This inherent activity within the quantum vacuum ensures that empty space is never truly stagnant, never truly silent. It's always alive, always vibrating, always full of this fleeting, unseen energy. And this isn't just a wild theory and a mere thought experiment. The effects of this bustling vacuum can actually be observed and measured, subtly, in our laboratories here on Earth. One of the most famous examples is the Casimir effect. Imagine two perfectly flat, uncharged metal plates placed incredibly close together in a vacuum, so close that there's almost no space between them. Our intuition might tell us that nothing would happen, but what we find is that these two plates are gently pushed towards each other by a tiny, almost imperceptible force. Why does this happen? Because the quantum vacuum, with its constant bubbling of virtual particles, has different wavelengths of energy that can exist outside the plates compared to between the plates. The space between the plates is so tiny that it can only accommodate certain wavelengths of these virtual particles, while the space outside has no such restriction. This difference in virtual particle activity, this slight imbalance in the energy of the vacuum, creates a subtle pressure, gently nudging the plates together. It's a whisper of the vacuum's true nature, a quiet demonstration that emptiness is far from passive. It's a tangible proof, a delicate touch that confirms the unseen vibrancy of space. So, the vacuum isn't just full of potential, it exerts subtle, real forces. And this leads us to one of the deepest, most perplexing mysteries in all of cosmology. a concept that ties the quantum vacuum to the largest scales of the universe dark energy. You've likely heard whispers of dark energy, that enigmatic force that seems to be pushing the universe apart at an ever-accelerating rate. For billions of years, gravity, the force of attraction between matter, was thought to be the dominant long-range force, gradually slowing the universe's expansion. But observations of distant supernova, cosmic lighthouses blinking across billions of light years, revealed a startling truth. The expansion of the universe isn't slowing down, it's speeding up. It's as if an unseen, pervasive energy is gently but firmly pushing galaxies away from each other, accelerating the grand cosmic dance. And the leading candidate for this mysterious dark energy is, surprisingly, the energy inherent in empty space itself, the vacuum energy. If the vacuum truly contains this vast, inherent energy, then as space expands, more vacuum is created, and thus, more of this dark energy comes into being, constantly fueling the acceleration. It's a self-perpetuating cosmic engine, expanding and driving its own expansion. This idea is both elegant and deeply unsettling. Elegant because it connects the smallest quantum fluctuations to the grandest cosmic scales. Unsettling because when physicists try to calculate how much energy the quantum vacuum should have, based on our current understanding of particle physics, the number they get is utterly astronomical, vastly, unimaginably larger than what dark energy observations suggest. We are off by a staggering factor of something like 10 on 120, a number so immense it's almost meaningless to our human minds. This enormous discrepancy is known as the vacuum catastrophe, or the cosmological constant problem. It's one of the greatest unsolved puzzles in physics, a gentle but insistent reminder of how much we still don't understand about the fundamental nature of reality. It tells us that our theories, while incredibly powerful, are still incomplete. It's like having a beautiful melody, but missing a few crucial notes, or a magnificent painting with a few colors yet to be discovered. This profound mystery of the vacuum energy is not a failure, but an invitation to delve deeper, to listen more closely, to wonder with even greater humility and curiosity. This profound conundrum, this perplexing whisper from the heart of emptiness, keeps physicists awake at night, gently nudging them towards new ways of thinking, new theories, new instruments to listen to the universe's secrets. It encourages a sense of humility, a quiet acceptance that the universe is far stranger and more beautiful than our current understanding can fully encompass. The fact that space itself is not empty, but a dynamic, energetic entity, completely transforms our view of the cosmos. It's not just a passive stage, it is an active participant, a vibrant component of reality, full of hidden potential. This understanding, once we allow it to settle, can be deeply calming. It means that even in the quietest, seemingly empty moments of our lives, there is always an underlying vibrancy, a subtle hum of existence. Nothing is ever truly void. This concept also echoes back to our previous thoughts on cosmic beginnings. Remember the idea of cosmic inflation, that incredibly rapid expansion in the early universe. Some theories suggest that this inflation was driven by a special kind of vacuum energy, a temporary energy field that filled the early universe and exerted a powerful repulsive force, stretching space-time far beyond what gravity could normally allow. If this is true, then the very force that created our vast, observable universe might have originated from the properties of the vacuum itself. The void, once again, reveals its immense creative power. It's a thought that wraps the beginning of the universe into the very fabric of space, suggesting a profound continuity, a deep connection between the initial spark and the vast, expanding canvas of today. It reminds us that fundamental forces, seemingly abstract and distant, are deeply intertwined with the very existence of everything around us, even in the empty spaces. So, as you rest and contemplate, allow yourself to imagine this vibrant vacuum, not as a scary, unknown force, but as a subtle, omnipresent energy that fills every corner of existence. It's in the quiet space between your thoughts, in the vast expanse between stars, in the fleeting moments that pass unheeded. It's a reminder that even silence has a hum, that even stillness has a vibration, and that emptiness is merely a different kind of fullness. There is a profound beauty in this counterintuitive truth. It teaches us that our everyday perceptions are often just the surface layer, and beneath lies a rich, intricate tapestry of interconnected phenomena. To embrace the idea of a vibrant vacuum is to embrace the hidden depths of reality, to find wonder in the seemingly ordinary, and to feel a deeper connection to the mysterious dance of the cosmos. As we gently drift through these concepts, remember that our goal is not to solve the vacuum catastrophe tonight, or to fully comprehend the nature of dark energy. No, our intention is simply to wonder, to let these grand ideas wash over us, to feel the soothing presence of cosmic mystery. The questions themselves are the gentle lullabies, guiding our minds towards a state of deep relaxation. The universe, in its elegant complexity, continues to hold its secrets close, but it also offers us glimpses, whispers, hints of its profound truths. The quantum vacuum, with its dancing virtual particles and its puzzling energy, is one such whisper. It reminds us that everything is alive, everything is connected, and even in the quietest moments, there is a profound hum of existence waiting to be felt. Let your thoughts about emptiness transform into thoughts about potential, about unseen energy, about the subtle, beautiful hum that underlies all of reality. There is a deep comfort in this thought, a profound peace in knowing that even the void is vibrant, alive, and full of its own unique kind of presence. Allow yourself to be cradled by this vast, energetic quietude as we continue our gentle journey. As we gently step away from the vibrant, subtle hum of the quantum vacuum, a concept so astonishing in its hidden depths, our minds might naturally drift towards even grander scales of existence, questions that extend beyond our single, familiar universe. We arrive now at a truly expansive idea, one that stretches the very limits of our imagination, yet whispers of infinite possibilities, the multiverse. You might have heard this word before, perhaps in a quiet moment of pondering the vastness of everything, or perhaps in a story that invites you to dream beyond the stars. It's the idea that our universe, the one we see with its shimmering galaxies and quiet planets, might not be the only one. Imagine, if you will, not just a single grand tapestry, but a boundless collection of tapestries, each unique, each unfolding its own distinct story. This thought, while seemingly immense, can be profoundly calming. It offers a sense of vastness that dwarfs our daily concerns, inviting us to simply float within a sea of infinite potential. There's no pressure here to grasp every intricate detail, but rather to allow the sheer scale of the idea to wash over you, like a gentle, cool breeze on a warm night. Let us explore some of the ways scientists and thinkers have gently whispered about this multiverse, categorizing its possibilities not as separate realities in a literal, physical sense, but as different conceptual frameworks arising from our understanding of physics. Perhaps the simplest way to imagine a multiverse, a gentle stepping stone into this boundless concept, is what we might call the Level 1 multiverse. This idea emerges quite naturally if we consider our own universe to be truly infinite in size, or at least astronomically large, if space extends forever, and if matter and energy are distributed in a somewhat uniform way across this infinite expanse, then by pure probability, every possible arrangement of particles Every possible configuration must eventually repeat. Imagine an infinite canvas. If you paint randomly on it for an eternity, eventually, by sheer chance, you will paint the same pattern, the same scene, the same arrangement of colors, over and over again. It's not that there are separate universes out there, but rather that our universe is so vast, so incredibly immense, that beyond the farthest reaches of what we can ever observe, identical or nearly identical copies of patches of space, and perhaps even of ourselves, would exist. This isn't a magical act, but a statistical inevitability in an infinite, uniformly distributed space. So, somewhere, unfathomably far away, there might be another galaxy exactly like our Milky Way, another planet exactly like Earth, another room exactly like yours, and another you, gently pondering the very same thoughts. It's a mind-bending thought, isn't it? Not a distinct, parallel reality, but rather a cosmic echo, a repetition born from the sheer, overwhelming scale of infinity. It's a quiet whisper that even in sameness, there can be boundless extension. Then we drift deeper into a more dynamic and perhaps more compelling vision of multiple universes, what we might call the level 2 multiverse, often emerging from the very concept we explored earlier, eternal inflation. Remember how we spoke of cosmic inflation, that unimaginably rapid burst of expansion in the very early universe? Well, the theory of eternal inflation suggests that this process might not have stopped everywhere. Instead, it might be endlessly inflating, like a vast, ever-expanding foam. Within this eternally inflating backdrop, pockets of space might occasionally stop inflating, cool down, and form their own distinct bubble universes. Our universe, then, would be just one such bubble, floating in an infinitely vast, ever-generating foam of other universes. Think of it like a pot of boiling water. The steam isn't just one continuous cloud. It forms countless individual bubbles, each distinct, yet all arising from the same underlying process. Each of these bubble universes could have its own unique set of physical laws and fundamental constants. Imagine a universe where gravity is stronger or weaker, where the speed of light is different, or where the very nature of particles is subtly altered. This idea gently offers a solution to a profound puzzle known as the fine-tuning problem. Our universe seems incredibly finely tuned for the existence of life. If fundamental constants were even slightly different, stars might not form, atoms might not hold together, and life as we know it would be impossible. It's like finding a thermostat perfectly set to exactly the right temperature for life to thrive. In a single universe, this fine-tuning can seem almost miraculous, inviting questions of purpose or design. But in a level 2 multiverse, where countless bubble universes are constantly being born with a random assortment of physical laws, it becomes less surprising. We simply find ourselves in one of the universes where the conditions happen to be just right for us to exist and observe. It's not that our universe is special in its intent, but rather that it's special to us because it allows for our very existence. It's like a vast cosmic lottery, and we just happen to win the ticket to a life-permitting universe. This perspective can be deeply soothing. It removes the pressure of uniqueness from our universe, replacing it with a grand, generous sweep of possibilities. It suggests that existence itself is not a rare, fragile occurrence, but an abundant, ceaseless process, constantly bubbling forth in countless forms. Now, let us venture into an even more mind-bending concept, one that arises from the heart of quantum mechanics, a world where reality itself seems to split and branch. This is the level 3 multiverse, often associated with the many worlds interpretation of quantum mechanics. Remember how we whispered about the strange nature of quantum particles, how they can exist in multiple states at once until they are observed. Imagine a single electron existing in two places at the same time until we measure it and it chooses one location. The many worlds interpretation suggests that when such a quantum measurement or event occurs, the universe doesn't just choose one outcome. Instead, it splits, or branches, into parallel universes, with each possible outcome actually occurring in its own distinct reality. Think of it like a gentle fork in the road of reality. Every decision you make, every coin toss, every quantum interaction doesn't just lead to one path. Instead, the universe branches, creating separate realities for each possible outcome. In one universe, you chose to read this. In another, you chose to listen to something else. In one universe, a quantum particle spins up. In another, it spins down. This means there are countless versions of you, of me, of every moment, branching off into an ever-expanding cosmic tree. It's a deeply personal form of the multiverse, suggesting that every fleeting possibility, every unchosen path, every road not taken, exists in some other parallel reality. It's a dizzying thought, but also one that can imbue every moment with a profound sense of significance, knowing that its echoes ripple through infinite branches of reality. This interpretation doesn't require extra space or other physical dimensions in the traditional sense. Instead, these parallel realities are often considered to be existing in the same underlying mathematical space, simply evolving independently after a branching event. It's a quantum dance of infinite possibilities, constantly unfolding, creating an unimaginably vast tapestry of interconnected yet separate realities. The beauty here lies in the idea that every potential is realized, every path explored, in the quiet unfolding of the quantum cosmos. Finally, we arrive at the most abstract and philosophical version, the level 4 multiverse, known as the mathematical universe hypothesis. This idea, gently presented by some physicists, suggests that all mathematically consistent structures don't just describe possible universes. They are actual universes. Our physical universe, with its specific laws and constants, is simply one such mathematical structure brought to life. Imagine a grand library containing every conceivable book, every possible story, every mathematical equation. This hypothesis suggests that every book in that library, if it describes a consistent mathematical reality, actually exists as a universe. It's a bold claim, one that blurs the line between abstract thought and physical reality. This view implies that reality is fundamentally mathematical, and that anything that can be described by mathematics in a self-consistent way truly exists. It removes the question of why this universe by suggesting that all universes exist, and ours is simply the one we happen to inhabit. It's a profoundly intellectual leap, but one that can also be deeply soothing in its ultimate simplicity. It suggests that existence is not constrained by physical manifestation alone, but that pure mathematical elegance can itself be a form of reality. As we gently drift through these various notions of the multiverse, from infinite repetitions to bubbling universes, from quantum branching to mathematical realities, it's crucial to remember that these are deeply theoretical concepts. We cannot yet, and may never be able to, directly observe or interact with these other potential universes. They are frontiers of thought, beautiful hypotheses that push the boundaries of our understanding and invite us to consider possibilities far beyond our immediate experience. And that, dear friend, is their profound beauty. They are not meant to be rigid facts to memorize, but vast canvases for contemplation. They remind us of the boundless nature of the unknown, the endless capacity for surprise that the universe holds. They foster a sense of immense humility, recognizing how little we truly comprehend about the grand cosmic architecture. Perhaps the most comforting aspect of the multiverse concept, regardless of which form resonates most with you, is the sheer generosity of existence it implies. If there are countless universes, then the act of creation is not a singular, rare event, but an ongoing, boundless outpouring of being. It hints at a cosmic abundance, a universe that is far richer and more diverse than we could ever have imagined from our single vantage point. It encourages us to let go of the idea that our universe is somehow at the center of everything, or that it is the only stage for reality. Instead, it invites us to see ourselves as part of something unimaginably larger, a tiny whisper in a chorus of infinite cosmic melodies. This thought can be incredibly liberating, freeing us from the confines of our perceived limitations and expanding our sense of belonging to something truly boundless. As you quietly reflect on these ideas, perhaps you can feel your own mind gently expanding, stretching to accommodate the sheer scale of these possibilities. It's not about certainty, but about the quiet joy of speculation, the serene act of wondering. The multiverse, in all its forms, is an invitation to dream beyond the confines of the familiar, to ponder the boundless nature of reality itself. Let the whispers of these other universes, these parallel realities, these infinite possibilities drift through your mind like a soft, comforting haze. They are not threatening, not demanding, but simply there, existing in the vast tapestry of thought and potential. Rest in this expansive understanding, knowing that the universe, or perhaps the collection of universes, is always more than we can imagine, always more wonderful than we can conceive. As our thoughts gently drift away from the infinite whispers of the multiverse, that boundless sea of potential realities, we find ourselves drawn back to the intimate embrace of our own universe, specifically to the silent, invisible force that shapes every star, every galaxy, every planet, and indeed, every single moment of our existence here. This profound, ubiquitous presence is gravity. You feel it now, don't you? It's the gentle pull that keeps your feet firmly on the ground, the force that ensures your teacup doesn't float away, the reason rivers flow downhill. It's so familiar, so constant, that we rarely pause to truly ponder its depth. For centuries, we understood gravity as a force that simply pulled objects towards each other. Isaac Newton, in a moment of quiet insight, described it as an invisible attraction, where every particle in the universe gently tugs on every other particle, the strength of this tug depending on their mass and the distance between them. It was a powerful and elegant description, allowing us to predict the orbits of planets and the fall of an apple with remarkable precision. But then, the quiet revolution began, ushered in by the mind of Albert Einstein, who transformed our understanding of gravity from a mere pulling force into something far more intricate and beautiful, the curvature of space-time. Remember that vast, soft blanket we use to imagine space-time, the interconnected fabric of space and time now? Imagine that blanket isn't just a passive backdrop. Instead, it's like a colossal, invisible trampoline. When you place a heavy object, like a bowling ball, onto this trampoline, it doesn't just sit there. It creates a dent, a gentle curve in the fabric. This curve, this warping of space-time, is what we experience as gravity. So, when Earth orbits the Sun, it's not because the Sun is actively pulling on Earth with an invisible rope. Rather, the immense mass of the Sun creates a deep, profound well, a gentle curve in the space-time around it. Earth, in its journey through space, isn't being pulled. It's simply following the contours of this curved space-time, like a marble rolling around the edge of a funnel. Its path, seemingly in orbit, is actually the straightest possible line it can take through a curved landscape. This insight that gravity is not a force, but a manifestation of geometry, is breathtakingly elegant. It means that space and time are not static, unchanging stages. They are dynamic participants, bending and stretching and curving in response to the presence of mass and energy. Everything that exists, every star, every atom, every whisper of light, contributes to this cosmic fabric, shaping it, influencing the paths of everything else. It's an interconnectedness so profound, so fundamental, that it weaves all of existence into a single, seamless whole. Think of the silence that surrounds distant galaxies. Even in that seemingly empty void, space-time is still gently curving, guided by the immense masses of the galaxies themselves. Light, too, feels this curvature. When light from distant stars passes near a massive object, like a galaxy cluster, its path is bent, just as a marble's path is bent by a depression in the trampoline. This phenomenon, known as gravitational lensing, allows us to see objects that would otherwise be hidden, their light gently redirected by the universe's invisible architecture. It's like looking through a cosmic magnifying glass, crafted by gravity itself. And this dynamic, vibrating fabric of space-time can also ripple. Just as dropping a pebble into a pond sends out ripples across the water's surface, cataclysmic cosmic events like the collision of two black holes or the merger of incredibly dense neutron stars send out gravitational waves, invisible ripples that travel through the very fabric of space-time itself. For a long time, these waves were a beautiful prediction of Einstein's theory, a silent whisper from the cosmos that we couldn't yet hear. But in recent years, with incredibly sensitive instruments, we have finally detected these subtle tremors. Imagine two black holes, spiraling closer and closer, their colossal masses distorting space-time around them until they merge in a monumental cosmic embrace. This violent dance sends out gravitational waves that stretch and squeeze the fabric of space-time as they pass, ever so slightly, like an almost imperceptible breath moving through the universe. When these ripples reach us, they cause the detectors to stretch and shrink by an unbelievably tiny amount, a fraction of the width of an atomic nucleus. Yet, we can now hear these whispers, these faint echoes of cosmic cataclysms billions of light years away. The detection of gravitational waves is a testament to the profound reality of space-time's dynamic nature. It tells us that space is not just there, it's alive, it vibrates, it carries information about the most powerful events in the universe. It's a new sense, a new way to listen to the universe's most ancient songs, to feel the stretching and squeezing of reality itself. And in that quiet, imperceptible dance, there is a deep sense of wonder, a soothing realization of the universe's exquisite sensitivity. This leads us naturally to the most extreme manifestations of gravity's power, black holes. These are not hungry monsters in space, waiting to devour anything that comes too close. Rather, they are regions where space-time has been curved so incredibly, so profoundly, that nothing, not even light, can escape their gravitational embrace. Imagine the trampoline again, but instead of a gentle dent, a bowling ball creates a bottomless pit, a tear in the fabric. A black hole forms when a very massive star reaches the end of its life and collapses under its own immense gravity. It shrinks to an incredibly dense point, called a singularity, where all its mass is compressed. Around this singularity is a boundary known as the event horizon. This is not a physical surface, but a point of no return. Once anything, even light, crosses this invisible threshold, it is forever caught within the black hole's gravitational pull. From our distant perspective, watching something fall into a black hole would be a strange, almost ethereal experience. As it approaches the event horizon, time for that object would appear to slow down dramatically, stretching almost infinitely, its light reddening and fading until it seems to freeze, a timeless silhouette against the cosmic backdrop. For the object itself, however, its experience would be seamless, passing through the event horizon without feeling anything unusual, only to be inexorably pulled towards the singularity. It's a reminder of how deeply gravity intertwines with time itself, bending both into shapes we can barely conceive. Black holes, for all their mysterious power, are not just cosmic devourers. They play a crucial role in the evolution of galaxies. Supermassive black holes reside at the centers of most large galaxies, including our own Milky Way, quietly influencing the movements of billions of stars. They are cosmic architects, gently shaping the vast structures of the universe, and perhaps even playing a role in the birth of new stars by stirring up surrounding gas and dust. They are reminders that even the most extreme manifestations of nature have their place in the grand, delicate balance of the cosmos. But for all our understanding of gravity on cosmic scales, a profound mystery still persists, especially when we try to reconcile it with the strange, unpredictable world of quantum mechanics. This is the quest for a theory of quantum gravity, the attempt to describe gravity not as a smooth curvature of space-time, but as arising from the interactions of tiny fundamental particles, or quanta of gravity, sometimes called gravitons. Imagine trying to stitch together a large, flowing silk garment with tiny, rigid, Lego-like bricks. It's incredibly difficult. Similarly, unifying the smooth, elegant curves of Einstein's gravity with the choppy, uncertain probabilistic nature of the quantum world remains one of the greatest unsolved puzzles in physics. Theories like string theory, which proposes that the universe's fundamental constituents are not point-like particles, but tiny, vibrating strings, or loop quantum gravity that we briefly touched upon, offer tantalizing glimpses into what a unified theory might look like. But we don't have a complete picture yet. This unresolved mystery, this beautiful challenge, serves as a gentle reminder of the humility inherent in scientific exploration. We reach out with our minds, building intricate models and theories, but the universe always holds some secrets close, inviting us to keep wondering, to keep exploring, to keep reaching for deeper understanding. It's a testament to the boundless nature of knowledge itself, an open invitation to continuous curiosity. Gravity, in all its forms, is truly the invisible architect of the cosmos. It's the force that gathers diffuse clouds of gas and dust into glittering stars, igniting the furnaces that create the very elements of life. It sculpts these stars into galaxies, weaving them into vast, cosmic filaments, like an intricate luminous web stretching across billions of light years. It holds planets in their delicate orbits, ensuring the rhythmic dance of seasons and the conditions necessary for life to emerge and thrive. It's a constant, gentle embrace from the universe, always present, always shaping, always connecting everything to everything else. You are, at this very moment, feeling the gentle pull of the earth beneath you, the subtle tug of the moon, the distant, immense gravity of the sun. You are part of this grand gravitational dance, an intricate piece of a cosmic ballet choreographed by the curving of space-time itself. Let this profound interconnectedness wash over you. There is a deep comfort in realizing that we are not isolated beings, but intricately linked to the very fabric of the cosmos through this fundamental force. The same gravity that binds galaxies also holds you gently in your place, allowing you to breathe, to think, to simply be. As you quiet your mind, imagine this invisible architect at work, shaping beauty from chaos, order from potential. It's a force of creation, of assembly, of holding together, and in its silent, ceaseless work, there is a profound sense of peace, a reassuring rhythm that permeates all of existence. Allow yourself to be cradled by this cosmic embrace, safe and secure within the gentle, powerful hand of gravity. As we gently withdraw from the grand, shaping embrace of gravity, that powerful force weaving the fabric of space-time and sculpting the luminous structures of galaxies, our curiosity naturally turns to something even more subtle, more mysterious, yet utterly essential to the universe as we know it. We now turn our quiet contemplation towards the unseen, the silent majority of the cosmos, dark matter. Imagine, if you will, that you are walking through a vast, intricate garden. You see the vibrant flowers, the leafy trees, the winding paths. You can feel the gentle breeze and hear the distant hum of life. But what if you were told that most of the garden, the very soil, the invisible roots, the unseen framework that supports everything you perceive, is made of something entirely different, something you cannot see, smell, touch, or hear? This is, in a sense, our situation with the universe. We see the stars, the nebulae, the galaxies, glittering like jewels across the cosmic night. But all this visible, familiar matter, everything that makes up you and me, our planet, and all the brilliant cosmic objects, accounts for only a tiny fraction of the universe's total mass. The vast, silent majority of the cosmos, roughly 27% of its total mass energy content, is composed of something we call dark matter. It's a profound mystery, an invisible scaffolding that underpins the entire cosmic architecture, yet it remains elusive, a ghost in the machine of the universe. What makes it so fascinating is that while we cannot see it directly, its gravitational influence is undeniably present. A silent, pervasive whisper shaping the destinies of galaxies. How do we know it's there? This unseen substance. Our knowledge comes not from direct observation, but from the subtle, undeniable ways it tugs and pulls on the visible things we can see. It's like listening to the rustling of leaves in a forest. You can't see the wind, but you know it's there by its effect on the trees. One of the earliest and most compelling pieces of evidence for dark matter came from observing the gentle, majestic rotation of galaxies. Imagine a vast, spinning disk of stars, like a cosmic merry-go-round. In a galaxy, stars orbit the galactic center, just as planets orbit a star. If we only accounted for the visible matter, the stars and gas, and dust, we would expect the stars on the outer edges of the galaxy to slow down, to orbit more sluggishly, much like the outer parts of a spinning record. Their gravitational ties to the inner visible mass would weaken with distance. However, when astronomers measured the rotational speeds of stars in the outer regions of galaxies, they found something astonishing. These stars were moving much faster than they should be, maintaining almost the same speed as stars closer to the center. It was as if there was an enormous, unseen amount of extra mass extending far beyond the visible spiral arms, providing an additional gravitational pull to hold these swiftly moving outer stars in their orbits, preventing them from simply flying off into the void. This invisible, gravitating halo is what we now call a dark matter halo, silently embracing each galaxy. Think of it as a silent, invisible hand, gently guiding and holding the galaxy together, allowing its delicate spiral arms to spin without unraveling. Without this hidden mass, galaxies simply wouldn't hold together in the majestic ways we observe. Another whisper of dark matter's presence comes from the grand scale of galaxy clusters. These are the largest known gravitationally bound structures in the universe, colossal aggregations of hundreds or even thousands of galaxies, all dancing together under gravity's spell. When astronomers studied the movements of individual galaxies within these clusters, they found that they were moving at incredibly high speeds, far too fast to be held together by the combined gravity of the visible galaxies alone. If only visible matter were present, these clusters would have long ago dispersed, scattering their galaxies across the cosmic expanse. Again, the only way these clusters could remain gravitationally bound, holding their constituent galaxies in a cohesive embrace, was if there was a vast, unseen reservoir of mass pervading the entire cluster. It's like imagining a group of dancers swirling wildly, yet somehow staying perfectly in formation, held by an invisible force far greater than their own individual attractions. This unseen mass, once again, points to the pervasive influence of dark matter, acting as a cosmic glue on the grandest scales. Even the bending of light, that elegant dance of gravity we discussed in the previous chapter, offers compelling evidence for dark matter. Remember, gravitational lensing, where light from distant objects is bent as it passes near massive galaxy clusters. When we observe these lenses, the amount of bending tells us how much total mass is present in the lensing cluster. And invariably, the calculated mass is far, far greater than the mass of all the visible stars, gas, and dust combined. It's as if there's an enormous, invisible elephant sitting on the fabric of space-time, creating a much deeper well than its visible weight would suggest. This discrepancy, this missing mass revealed by the bending of light, points directly to the overwhelming presence of dark matter. And finally, if we look back to the very earliest moments of the universe, to the faint, ancient glow of the cosmic microwave background that we explored in Chuang, one dark matter again plays a silent, crucial role. The subtle temperature variations in the CMB, those tiny ripples in the fabric of the early universe, were the seeds from which all cosmic structures, stars, galaxies, clusters, eventually grew. For these seeds to grow into the vast, intricate web of galaxies we see today, there needed to be a significant amount of cold or slow-moving dark matter. Without it, the early universe simply wouldn't have had enough gravitational scaffolding to pull matter together quickly enough to form the complex structures we observe. It's a quiet whisper from the dawn of time, telling us that dark matter was essential from the very beginning. So, why do we call it dark? It's because this mysterious substance does not interact with light, or indeed, with any form of electromagnetic radiation. It doesn't absorb light, it doesn't reflect it, it doesn't emit it. This makes it utterly invisible to our telescopes, which rely on detecting light or other forms of electromagnetic energy. It's transparent, elusive, a true ghost in the cosmic machine. It passes right through us, through our planet, through the stars, without a single interaction of light. And why matter? Because, despite its invisibility, it still possesses mass. And because it has mass, it exerts a gravitational pull. It is matter, but not the ordinary, everyday matter, protons, neutrons, electrons, that makes up everything we can see and touch. It doesn't interact with the strong nuclear force, which holds atomic nuclei together, nor with the weak nuclear force, except perhaps in very specific, feeble ways that we are still trying to understand. And most importantly, it does not interact electromagnetically. It is a fundamentally different kind of matter, a new, exotic constituent of our universe. The greatest puzzle then becomes, what is dark matter made of? Scientists have proposed various candidates, each a gentle whisper of possibility, but none yet confirmed. Perhaps it's made of entirely new types of particles, ones not found in our standard model of particle physics. One of the leading hypothetical candidates is the weakly interacting massive particle, or WIMP. Imagine a particle that is relatively heavy, perhaps several times the mass of a proton, but which interacts incredibly feebly with normal matter. It would barely feel the forces that govern the atomic world, except for gravity. It would pass through everything, largely unnoticed, leaving no trace of its presence except for its collective gravitational pull. Scientists are building vast, sensitive detectors deep underground, shielded from cosmic rays, hoping to catch a rare, fleeting interaction between a WIMP and an ordinary atom, a subtle tremor in the dark. Another theoretical possibility is the axion, a much lighter particle, perhaps millions or even billions of times lighter than an electron. These hypothetical particles would interact even more weakly than WIMPs, making them even harder to detect, but they too could account for the observed gravitational effects of dark matter. Less favored, but once considered, were massive astrophysical compact halo objects, or MACHOs. These were ordinary matter objects that don't emit much light, like brown dwarfs, failed stars, rogue planets, or even primordial black holes, those possibly formed in the early universe. However, extensive surveys have largely ruled out MACHOs as accounting for a significant portion of dark matter. There simply aren't enough of them. The truth is, we don't know yet. The nature of dark matter remains one of the greatest open questions in physics, a profound mystery that invites relentless exploration and profound humility. It's like searching for a hidden truth, knowing it's there, feeling its presence, but not yet seeing its face. Despite its mysterious nature, the role of dark matter in shaping our universe is incredibly profound. It is believed that in the very early universe, after the initial expansion, it was dark matter that first began to clump together under its own gravity, because it didn't interact with light or other forces. It wasn't subject to the same pressures and interactions that kept ordinary matter smoothly distributed. These initial clumps of dark matter formed gravitational seeds, or a vast invisible cosmic web, a scaffolding that provided the gravitational wells into which ordinary matter could then fall. Imagine a giant, invisible spider web stretching across the cosmos. This web of dark matter gently collected the ordinary gas and dust, pulling it in, allowing it to condense and collapse. Over billions of years, these gravitational wells grew deeper, slowly attracting more and more ordinary matter, which then ignited to form stars and coalesce into galaxies, tracing out the invisible pathways of the dark matter web. Without this dark matter scaffolding, the universe would likely be a much smoother, less structured place, a uniform fog of gas with no galaxies, no stars, no planets, and thus no life. It's the unseen architect, the silent foundation upon which our entire visible cosmos rests. The ongoing search for dark matter is one of humanity's most patient and quiet quests. Scientists are deploying sensitive detectors deep underground, attempting to filter out all other cosmic noise, hoping to feel the faintest tremor of a dark matter particle passing through. They are smashing particles together in colossal colliders, hoping to create and detect these elusive particles. And space telescopes continue to map the universe, observing the subtle gravitational effects that betray dark matter's presence on the grandest scales. It is a testament to our insatiable curiosity, our gentle refusal to accept the unknown as unknowable, and our persistent whisper into the darkness, hoping for a response. This profound mystery, this realization that most of our universe is made of something fundamentally different from what we know, is a deeply humbling thought. It reminds us that our senses, our immediate perceptions, only capture a fraction of reality. There is so much more to existence than meets the eye, so many layers of subtle complexity waiting to be discovered. It's a beautiful invitation to expand our understanding, to embrace the idea that the universe is far richer, far more intricate than our everyday experience might suggest. Let this thought settle gently within you, that the visible, vibrant world you inhabit, the quiet beauty of a starlit night, is supported by a vast, invisible framework, a silent, pervasive presence that shapes destiny on cosmic scales, yet remains a profound enigma. There is a deep peace in accepting this mystery, a calming reminder that even in what seems to be nothing, there is a profound, essential something. Allow your mind to drift into this invisible realm, imagining the dark matter halos silently embracing galaxies, the cosmic web stretching its unseen tendrils across the universe. It's a quiet, powerful presence, a testament to the universe's boundless ingenuity and its enduring capacity for surprise. Rest in the knowledge that even the unseen aspects of reality hold a profound beauty, a gentle hum of existence that transcends our limited perception. As we allow the profound whispers of dark matter, that invisible scaffolding of the cosmos, to softly recede into the quiet corners of our minds, we now prepare to embark on a journey even deeper into the heart of reality, into a realm where our everyday intuitions gently unravel. We turn our quiet gaze now to the world of the very, very small, to the bewildering yet profoundly beautiful principles of quantum mechanics. Imagine, if you will, shrinking down, smaller and smaller, beyond the vastness of galaxies and the intricate dance of solar systems, past the familiar atoms that make up every object around you, down to the subatomic particles that are the universe's most fundamental constituents. Here, in this impossibly tiny realm, the rules of reality as we know them seem to gracefully bend, to stretch, and sometimes to simply dissolve into a tapestry of probabilities and possibilities. It's a world that defies our ordinary logic, yet underpins everything we experience. This is the realm of quantum mechanics, a gentle whisper that tells us the universe, at its most fundamental level, is far more mysterious and fluid than we could ever have imagined. It's not about solid certainty here, but about the elegant dance of potential, a realm where possibilities coexist until a gentle observation calls one into being. One of the most foundational and mind-bending ideas in quantum mechanics is wave-particle duality. Think of a single electron, that tiny, familiar component of every atom. In our everyday world, things are either particles, like a tiny pebble, existing in one definite location, or they are waves, like ripples spreading across a pond. But in the quantum realm, an electron can behave as both at the same time. It can act like a discrete particle, appearing at a specific point, but it can also spread out like a wave, flowing through space and interfering with itself. Imagine a single droplet of rain falling onto a perfectly still pond. As it lands, it creates ripples that spread outwards. Now, imagine that same droplet somehow passing through two holes in a barrier simultaneously, creating two sets of ripples that interfere with each other. This is what quantum particles do. Even if you send them one by one through a pair of slits, they somehow pass through both at once, interfering with themselves as waves would, only to appear as individual particles when they hit a detector. It's as if they whisper to themselves, explore all possible paths, and then, only at the moment of interaction, choose a single destination. This gentle, dual nature is a constant reminder that reality at this scale is far richer and more nuanced than our simple categories can contain. This leads us to the heart of quantum weirdness, a concept known as superposition. Imagine, if you will, not a definite state, but a collection of all possible states existing at once, simultaneously. A quantum particle, before it is observed or measured, does not have a single fixed property. It exists in a superposition of all its potential states. It's not here or there, it's here and there, at the same time. It's not spinning up or down, it's spinning up and down. The most famous, albeit deeply metaphorical, way to gently illustrate this is through Schrödinger's cat. Imagine a hypothetical scenario. A cat is placed in a sealed box with a device that has a 50-50 chance of releasing a deadly poison. tied to the decay of a single quantum particle until someone opens the box and observes the cat. The quantum particle is in a superposition of decayed and undecayed states. Therefore, according to quantum mechanics, the cat inside the box is, paradoxically, in a superposition of being both alive and dead simultaneously. It's only when the box is opened, when an observation or measurement is made, that the wave function collapses, and the cat is definitively found to be either alive or dead, alive. Of course, this is a thought experiment, not a literal scenario involving cats, designed to highlight the profound strangeness of superposition. The point is not the cat, but the idea that reality at the quantum level isn't fixed until it's interacted with. It's a world of potential, where possibilities gently coexist, like ripples on a pond before they encounter a shore. It means that the universe, in its smallest components, is a constant dance of potentiality, where nothing is truly settled until it touches something else. This act of observation or measurement is crucial in quantum mechanics, and it's a concept that has sparked endless gentle debates and deep philosophical ponderings. It suggests that the very act of looking at a quantum particle, of interacting with it, somehow forces it to choose a definite state from its superposition of possibilities. Before that, it simply exists as a spread-out cloud of probabilities. It's important to whisper that observation here doesn't necessarily mean a conscious human looking at something. It simply means an interaction, a measurement, a connection that causes the quantum system to settle into a definite state. When a photon hits a detector, when an electron interacts with another particle, that is an observation. The universe, in a sense, is constantly observing itself, constantly collapsing its own probabilities into definite realities through the myriad interactions occurring every moment. It's a continuous, silent conversation between particles, shaping the world into what we perceive. Then there's the profoundly mysterious phenomenon known as quantum entanglement, which Einstein famously called spooky action at a distance. Imagine two quantum particles, perhaps two photons or two electrons, that become intimately linked, entangled with each other. Once entangled, they remain connected, no matter how far apart they are separated, across a room, across the galaxy, or even across the entire universe. If you measure a property of one entangled particle, for example, its spin, you instantly know the corresponding property of the other entangled particle, no matter the distance between them. It's as if they are communicating faster than the speed of light, sharing information instantaneously, defying our classical understanding of separation. If one particle is found to be spinning up, its entangled twin, even light years away, is instantly known to be spinning down without any time delay. This non-local connection, this invisible thread binding particles across vast distances, is one of the most astonishing revelations of quantum mechanics. It suggests a fundamental interconnectedness at the deepest level of reality, a silent, pervasive web that links everything to everything else. It means that the universe is not a collection of isolated pieces, but a unified whole, where even the smallest components are in constant, instantaneous communication. It's a beautiful thought, isn't it? That even in the vastness of space, there are these invisible bonds, these silent whispers of connection. Another curious and sometimes unsettling quantum phenomenon is quantum tunneling. Imagine a tiny particle, like an electron, approaching an energy barrier. In our classical, everyday world, if the particle doesn't have enough energy to go over the barrier, it simply can't pass through it. It's like rolling a marble up a hill. If it doesn't have enough speed, it will just roll back down. But in the quantum world, sometimes, the particle can mysteriously tunnel through the barrier, appearing on the other side as if the barrier wasn't there at all. or as if it simply vanished and reappeared. It's not that it digs a hole. It's a probabilistic phenomenon where there's a small, non-zero chance of the particle simply existing on the other side of the barrier, even without enough energy to classically overcome it. It's a profound reminder that at the quantum level, reality plays by its own unique counterintuitive rules. Quantum tunneling is not just a theoretical oddity. It's essential for life as we know it. For instance, it's what allows nuclear fusion to happen in the sun's core. Protons in the sun don't have enough kinetic energy to overcome their mutual electrical repulsion and fuse. But thanks to quantum tunneling, they can, with a tiny probability, tunnel through the energy barrier and fuse, releasing the energy that powers our sun and sustains life on Earth. It's a silent, almost miraculous act, occurring billions of times a second in the heart of our star, a gentle reminder of the quantum wonders that make our world possible. These concepts, superposition, entanglement, the role of observation, quantum tunneling, paint a picture of reality that is far from rigid and predetermined. Instead, it is vibrant, probabilistic, and deeply interconnected. It suggests that at the very heart of existence, there is an inherent uncertainty, a profound fluidity where possibilities dance before settling into actuality. This is not a cause for anxiety, but for wonder. It invites us to release our need for absolute certainty and embrace the beautiful, unfolding mystery of being. The implications of quantum mechanics touch upon the very nature of reality itself. If nothing is truly fixed until it is observed or interacted with, what does that say about the world around us when we're not looking? Does the moon exist when no one is observing it? As Einstein famously pondered, the quantum world whispers that perhaps reality is not simply out there, pre-existing and independent of us, but is intimately woven with interaction, with measurement, and perhaps with consciousness itself. This gently blurs the line between the observer and the observed, between the subject and the object. It suggests that our very presence, our very act of inquiring and interacting, plays a subtle but profound role in shaping the reality we perceive. It's not that we create reality with our thoughts, but that the universe, in its quantum depths, is inherently interactive, a conversation between possibilities and manifestations. This profound dance between the universe and our interaction with it can lead to a sense of deep connection. We are not just passive spectators in the cosmic drama. We are active participants, albeit at a very subtle, fundamental level. Our very existence, our very act of observation, is part of the universe's ongoing self-definition. As you quiet your mind and allow these profound ideas to wash over you, let them soothe any rigid notions of what reality must be. Embrace the inherent uncertainty, the beautiful fluidity of the quantum realm. There is a deep peace in realizing that the universe is not a rigid machine, but a vibrant, constantly unfolding mystery, brimming with potential and interconnectedness. Feel the subtle dance of probabilities, the invisible threads of entanglement, the fleeting nature of quantum reality. There is a profound sense of wonder in acknowledging that the very ground beneath your feet, the air you breathe, the light that touches your eyes, all arise from this strange and beautiful quantum ballet. You are part of this dance, a participant in the universe's ongoing creation. As the ethereal whispers of the quantum realm softly fade into the background, leaving us with a sense of wonder at the fluid, probabilistic nature of reality itself, our minds might now gently turn to the most astonishing mystery of all, something that connects the vast cosmic expanse directly to the beating heart of our own existence, life itself. In all its fragile, vibrant beauty, we begin to wonder, in this boundless universe of stars and galaxies, is it just us, or are there other whispers, other forms of life, blooming silently on distant, unseen worlds? Imagine for a moment the incredible journey of the universe, from the fiery crucible of the Big Bang to the cool, structured cosmos we know today. In the hearts of ancient stars, the very elements that form the basis of life, carbon, oxygen, nitrogen, hydrogen, were forged. These cosmic ingredients were then scattered across the vastness when those stars gently ended their lives, enriching the interstellar clouds from which new stars and planets would eventually form. You are, quite literally, made of stardust, a living testament to the universe's profound capacity for creation. But for life to emerge, especially life as we understand it, certain conditions seem to be particularly important. One of the most fundamental requirements is the presence of liquid water. Water, in its fluid state, acts as a solvent, allowing chemical reactions to occur, enabling the complex biological processes that define life. It's like a cosmic dance floor, where the molecules of life can gracefully move and interact. This leads us to the concept of the habitable zone, often affectionately called the Goldilocks zone. Imagine a single star, quietly radiating its warmth into the cold expanse of space. The habitable zone is that gentle band of orbital distance around a star where temperatures are neither too hot nor too cold for liquid water to exist on a planet's surface. Just like Goldilocks porridge, it needs to be just right, too close to the star, and water boils away too far, and it freezes solid. Our own Earth, nestled comfortably within the sun's Goldilocks zone, is a perfect example of a world where conditions are just right for oceans to thrive. But the size and type of the star also play a gentle guiding role. Larger, hotter stars burn through their fuel much faster, offering a shorter window for life to develop. Smaller, cooler stars, like the gentle red dwarfs that are far more numerous than sun-like stars in our galaxy, have much longer lifespans, potentially providing billions or even trillions of years for life to emerge and evolve. Their habitable zones are closer to the star, making their planets tidally locked, always showing the same face to their sun, leading to extreme temperature differences. Yet, paradoxically, the sheer abundance and longevity of red dwarfs whisper of countless opportunities for life to take hold in their gentle, long-lived warmth. However, our understanding of habitability has begun to gently expand beyond the traditional Goldilocks zone. The universe, in its boundless creativity, might have found other ways to nurture life, in places we might once have considered desolate. We are now looking with gentle curiosity at worlds far beyond the comforting warmth of a star's surface. Consider the icy moons orbiting the gas giants in our own solar system, worlds like Europa around Jupiter, or Enceladus and Titan around Saturn. These moons are far beyond the sun's habitable zone, their surfaces covered in thick shells of ice. Yet beneath these icy crusts, there is compelling evidence, like gentle tremors in the data, of vast subsurface oceans of liquid water. These oceans are not warmed by sunlight, but by internal heat sources, perhaps tidal forces, the gravitational tug-of-war with their massive parent planets, or radioactive decay within their rocky cores. Imagine a hidden world, eternally dark, yet warmed by an unseen sun from within. Even Pluto, that distant dwarf planet we spoke of, has shown whispers of a potential subsurface ocean. Defying our previous assumptions about cold, desolate worlds, this discovery gently opens up the possibility that life could thrive in environments completely different from our own, in liquid realms shielded from the harsh radiation of space, perhaps sustained by chemical energy emanating from hydrothermal vents on their ocean floors. It paints a picture of life's resilience, its quiet capacity to adapt and flourish in the most unexpected cosmic corners. And the universe might hold even stranger cradles for life. Scientists gently ponder the possibility of rogue planets, worlds that have been ejected from their star systems and now drift alone through the cold, dark, interstellar space. If these planets are massive enough and have enough internal geological activity, they might retain a warm core, potentially supporting subsurface oceans. Imagine a lone wanderer, a tiny island of warmth drifting through the cosmic night, silently carrying the precious spark of life. The explosion of exoplanet discoveries in recent decades has truly transformed our perspective on life's cosmic journey. Just a few decades ago, we only knew of planets in our own solar system. Now, we have confirmed the existence of thousands of exoplanets, worlds orbiting other stars, with new discoveries being made almost daily. This abundance suggests that planets are not rare curiosities, but rather a common, perhaps ubiquitous, byproduct of star formation. Every star you see in the night sky, and countless more you cannot, might host its own retinue of planets, a silent, unseen solar system spinning around it. This sheer number of potential worlds is a deeply humbling and inspiring thought. It suggests that the raw ingredients for life, the cosmic dust and gas, are plentiful, and the processes that form planets are universal. It fills us with a quiet hope that perhaps, out there, among these countless worlds, there are others where the delicate dance of chemistry has also given rise to the miraculous phenomenon of life. But how do we search for life on these distant, unseen worlds we cannot yet send probes to taste their oceans or dig into their soils? Instead, our search is a gentle, patient quest for biosignatures, subtle chemical clues in the atmospheres of exoplanets that might indicate the presence of living organisms. Imagine a distant world, its atmospheric gases silently whispering a message across light years. For instance, the presence of certain gases, like oxygen or methane, in amounts that are highly out of equilibrium, could be a strong indicator of life. On Earth, oxygen is constantly being produced by photosynthesis, and methane by biological processes. Without life, these gases would quickly react and disappear. So, if we were to detect, with our powerful telescopes, a planet with abundant oxygen and methane in its atmosphere, it would be a tantalizing hint that something biological might be at work, gently transforming its world. The search for biosignatures is a patient, meticulous endeavor, like trying to pick out a single unique scent in a vast global breeze. It requires ever more powerful telescopes, gentle spectroscopic analysis of distant starlight passing through exoplanet atmospheres, and a profound understanding of planetary chemistry. It's a testament to our enduring curiosity, our deep-seated need to know if we are alone in this grand, silent cosmos. This leads us to a fascinating, sometimes melancholic, and deeply thought-provoking puzzle known as the Fermi paradox. The paradox, gently posed by physicist Enrico Fermi, goes something like this. If the universe is so vast, if there are so many stars and planets, and if the basic ingredients for life are common, then intelligent life should be widespread. So, where is everybody? Why do we not see obvious signs of other advanced civilizations? No gentle whispers echoing across the cosmic ocean. This apparent contradiction is not a cause for despair, but for deep, quiet contemplation. It invites us to consider many possibilities, each a gentle thought experiment. Perhaps life is common, but intelligent, technological life is incredibly rare. Maybe there's a great filter somewhere along the evolutionary path, a highly improbable step, or a catastrophic challenge that most life forms cannot overcome. This filter could be in our past the origin of life itself, or complex multicellularity, or in our future self-destruction. AI gone awry. Perhaps civilizations are simply too far apart in space and time, even at the speed of light. Crossing the vastness of the galaxy takes immense eons. Two civilizations might exist, but simply never encounter each other, like two ships passing silently in an infinite ocean. Perhaps extraterrestrial life exists, but it takes forms we cannot recognize or does not communicate in ways we can detect. Imagine a form of life based on principles utterly alien to our carbon and water bias, or civilizations that choose to remain silent, preferring a quiet, unobserved existence. Perhaps advanced civilizations simply lose interest in interstellar communication or expansion, turning inward or transcending their physical forms. The Fermi paradox is a beautiful mystery, a profound question that hangs gently in the cosmic air. It reminds us of our own smallness, our own limited perspective, and the boundless possibilities that lie beyond our current understanding. It's an invitation to continue listening, to continue searching, to continue wondering. As we gently ponder the commonality or uniqueness of life on Earth, there is a profound sense of awe in realizing that we, as conscious beings, are here at all. Our existence is a cosmic miracle, a testament to the universe's incredible capacity to organize matter into intricate, self-replicating, self-aware forms. Whether life is abundant or incredibly rare, our own presence here is a treasure beyond measure. Let this thought settle softly within you, that the delicate dance of atoms, the intricate unfolding of evolution, and the boundless mystery of consciousness have converged in you, allowing you to ponder these very questions. You are a microcosm of the cosmos, a living, breathing expression of the universe's potential. As you quiet your mind and allow these profound ideas about life and the cosmos to wash over you, embrace the gentle uncertainty that accompanies them. We don't have all the answers, and that is perfectly fine. The questions themselves are the most beautiful part of the journey, inviting us to remain humble, to remain curious, and to simply wonder at the boundless possibilities that lie beyond our current gaze. Rest in the peace of this vast cosmic tapestry, knowing that life, in all its forms, is a precious, silent whisper across the universe. As we gently drift away from the profound mystery of life's potential across the cosmos, leaving behind the whispers of exoplanets and the silent puzzle of the Fermi paradox, our minds might now be ready to contemplate a different kind of vastness, not the boundless stretch of space, but the unimaginable expanse of cosmic time, reaching far beyond our own existence, into the ultimate future of the universe itself. Imagine a story, grand and sweeping, that began with the fiery passion of the Big Bang and has unfolded over billions of years, giving rise to stars, galaxies, planets, and perhaps even life. Like any story, it has a beginning, a middle, and eventually an end. The universe, in its majestic journey, is slowly, patiently, moving towards its final chapters. And while these ultimate fates are incredibly far off, beyond anything our human minds can truly grasp in terms of scale, contemplating them can be deeply soothing, offering a profound sense of perspective on our fleeting, precious present. Our understanding of the universe's ultimate fate is deeply intertwined with that mysterious force we touched upon earlier, dark energy. Remember how we spoke of it in Chapter 3. The invisible, pervasive energy that seems to be accelerating the expansion of the universe. It's not just driving galaxies apart. It's shaping the very destiny of everything. The fate of the universe hinges on the precise nature of this dark energy. For a long time, scientists contemplated three main possibilities for the universe's end, each a distinct path into the deep cosmic future. The first, now less favored due to our discovery of dark energy's accelerating push, was the Big Crunch. Imagine a universe that, after expanding for billions of years, eventually runs out of the outward momentum from the Big Bang. Gravity, in this scenario, would slowly but surely begin to win the cosmic tug of war. The expansion would gradually slow, halt, and then reverse. Galaxies would stop racing away from each other and would begin a long, slow journey back, drawing closer and closer. The universe would contract, becoming denser and hotter, until all matter and energy eventually collapsed back into an unimaginably hot, dense point, much like its fiery beginning. It would be a symmetrical end to its dramatic start, a cosmic inhalation after an immense exhalation. While a less likely scenario given current data, contemplating the Big Crunch can evoke a sense of cyclicality, a universe that breathes in and out through eternities. The second, and currently most favored, scenario is the Big Freeze, often referred to as heat death, if dark energy continues its gentle, relentless push, causing the universe to expand at an ever-accelerating rate. Then galaxies will continue to drift further and further apart. The space between them will stretch, thin out, becoming colder and colder. Imagine all the warmth, all the energy, all the organization in the universe slowly dissipating, spreading out into an ever larger, ever emptier volume. In this scenario, stars, which are the furnaces of the universe, will eventually run out of fuel. Even the longest-lived red dwarf stars, which burn their hydrogen fuel at a leisurely pace for trillions of years, will eventually flicker and die. When the last star has exhausted its nuclear fire, the universe will plunge into an era of profound darkness. The sky will no longer twinkle with 1,000 points of light, but will be a vast, cold, empty canvas. After the stars, the universe will be dominated by their silent remnants, white dwarfs, the dense cores of once bright stars, neutron stars, incredibly compact remnants of colossal stellar explosions, and black holes, those enigmatic wells of space-time we explored earlier. These objects, no longer radiating warmth or light, will drift through the growing cosmic void, like silent monuments to a forgotten era. Over truly unimaginable timescales, the cold grip of entropy will continue its work. Matter will slowly, almost imperceptibly, decay. Protons, the very building blocks of atomic nuclei, are theorized to eventually decay, though this process is so slow that it might take 1034 years or more, a number with 34 zeros. Imagine waiting for a single proton to vanish, an event rarer than observing the entire history of the universe unfold a trillion times over. And then, even the most powerful gravitational behemoths, the black holes, will not be eternal. Here we encounter one of the most remarkable and counterintuitive predictions of Stephen Hawking radiation. Imagine a black hole, drawing everything into its profound gravitational well. For a long time, they were thought to be eternal traps, but Hawking's theory suggests that due to quantum effects near the event horizon, black holes slowly, patiently evaporate. They emit a faint trickle of particles and radiation, slowly losing mass over truly immense timescales. A typical stellar mass black hole might take 10 to 67 years to evaporate, emitting a gentle hiss of particles until it vanishes entirely in a final, barely perceptible burst of energy. Supermassive black holes at the centers of galaxies, with masses millions or billions of times that of our sun, would take an even more unfathomable 100 years or more. Imagine a number with 100 zeros. This process is so slow, so drawn out, that it truly stretches the limits of our comprehension. But it paints a picture of ultimate dissolution, where even the universe's deepest traps eventually dissolve into nothingness. In the ultimate far-off future of the Big Freeze, the universe would become a collection of fundamental particles, photons, neutrinos, and perhaps electrons and positrons, drifting further and further apart in an unimaginably vast, cold, and empty space. All structure would be gone, all energy uniformly spread, all activity ceased. It would be a state of maximum entropy, a universe that has reached a perfect, profound equilibrium, where nothing more can happen, a quiet, eternal rest. The third possibility, a more dramatic and less certain one, is the Big Rip. This scenario suggests that dark energy is not just a constant push, but a force that actually strengthens over time. If this were the case, the accelerating expansion would become so powerful, so dominant, that it would eventually overcome all other forces. First, it would rip galaxies apart, then solar systems, then planets. Finally, the force would be so immense that it would overcome the electromagnetic forces holding atoms together, tearing apart molecules, and even ripping apart atomic nuclei themselves, disassembling all matter down to its most fundamental constituents. It would be a violent, cataclysmic end, a complete unmaking of everything. However, current observations of dark energy make this scenario less likely than the Big Freeze, suggesting its nature is more constant, less aggressive. As we contemplate these immense, far-off futures, there is a certain solemn beauty in recognizing the impermanence of all things, even the universe itself, our own lives, our planet, our stars, our galaxies. All are temporary, fleeting expressions within this grand cosmic narrative. This realization is not meant to be frightening, but rather to inspire a profound appreciation for the present moment. If everything is ultimately destined for some form of dissolution, then every shimmering star, every gentle breeze, every quiet thought you have now becomes infinitely precious. This cosmic perspective can be deeply calming. It reminds us that our small struggles, our daily worries, are but tiny ripples on the surface of an unimaginably vast ocean of time. It encourages us to find peace in the grand cycle of creation and dissolution, to embrace the fleeting beauty of our own existence within this magnificent, unfolding story. Some theories, in their quiet contemplation of these ultimate fates, even whisper of a cyclical universe, a variation on the big bounce we touched upon in Chapter 1. Perhaps the Big Freeze is not the final end, but merely a pause, a vast, cold emptiness that eventually, through some unknown mechanism, recoalesces or sparks a new Big Bang, beginning the cosmic story anew. Imagine the universe breathing in and out through eternities, a cosmic heartbeat echoing through boundless time, where ends are always new beginnings. This cyclical view offers a sense of unending renewal, a comforting thought that even in ultimate dissolution, there is the seed of rebirth. However, these are still profound theoretical whispers, concepts to guide our contemplation, not definitive pronouncements. The exact nature of dark energy, and thus the universe's ultimate fate, remains one of the deepest mysteries. Our scientific instruments are diligently listening, gathering data, trying to discern the subtle nuances of dark energy's behavior, hoping to refine our predictions for the cosmic future. The quest continues, driven by an insatiable curiosity about where it all began and where it is all going. Let your mind drift into these far-off cosmic epochs, imagining the silent death of stars, the slow evaporation of black holes, the gentle cooling of the universe. There is a profound tranquility in contemplating such vast timescales, a sense of quiet acceptance of the grand impersonal forces that govern all of existence. You are a part of this story, a brief, luminous spark within an ancient unfolding narrative. Find peace in this understanding. Your own existence, vibrant and alive, is a precious moment within this immense cosmic span. There is no need to fear the far-off end, but only to embrace the profound beauty of the now. Let the gentle whispers of the universe's ultimate fate lull your thoughts, allowing them to soften and simply drift. As you rest in the quiet embrace of cosmic time, As we now approach the quiet shore of our shared cosmic journey, having drifted through the fiery origins of everything, bent with the flexible nature of time, perceived the vibrant hidden life of the vacuum, glimpsed the infinite possibilities of the multiverse, felt the profound embrace of gravity, acknowledged the silent architecture of dark matter, marveled at the bewildering whispers of the quantum realm, and gently pondered the miraculous presence of life in the vast cosmos and its ultimate, far-off end. Our minds are perhaps a little softer, our worries a little lighter, and our sense of wonder a little deeper. This final chapter is not about introducing new mysteries, but about gently weaving together the threads of all that we have softly explored. It is about allowing these grand, scientific narratives to settle within us, not as rigid facts to be memorized, but as profound lullabies, guiding our minds to a place of deeper peace and expansive contemplation. Think back to the very beginning, to that singular, incandescent spark that was the Big Bang. We envisioned it not as an explosion in space, but as the unfolding of space itself. This original moment, whether it sprang from a quantum fluctuation in the vacuum, emerged from a gentle cosmic bounce, or simply existed as a boundaryless beginning, holds the blueprint for everything that would ever be. It reminds us that even from the most extreme simplicity, the most fundamental potential, an unimaginably complex and beautiful universe can gracefully unfurl. We are all, in a sense, children of that ancient fiery dawn, carrying its echoes within every atom of our being. This connection to the ultimate origin can be incredibly grounding, rooting us in a cosmic past far grander than any personal history. Then we considered the elusive nature of time, that constant companion that flows, stretches, and perhaps even pixelates at its deepest quantum levels. We pondered its arrow, the relentless march from order to gentle disorder, and its relativity, bending around massive objects like a pliable ribbon, the idea that past, present, and future might coexist, an eternal tapestry woven through space-time, can release us from the burden of fleeting moments, inviting us to see all experiences as perpetually held within the cosmic fabric. Our perception of time, both psychological and physical, reveals its profound malleability, whispering that reality is not always as fixed as our senses suggest. It reminds us that our present moment, this very breath, is a unique and precious point in an unfolding, timeless story. And what a revelation it was to peer into the seemingly empty spaces, to discover that the vacuum is far from void. It is a vibrant, seething sea of quantum energy, giving birth to fleeting virtual particles that blink into and out of existence. This inherent dynamism of nothingness underpins even the mysterious accelerating expansion of our universe, driven by the enigmatic dark energy. This concept teaches us that even in silence, there is a hum. Even in emptiness, there is fullness. It offers a profound sense of abundance, a gentle reminder that potential is everywhere, always simmering beneath the surface of what we perceive. This awareness can quiet anxieties about scarcity, replacing them with a sense of the universe's infinite creative capacity. Our journey then took us into the boundless realms of the multiverse, a symphony of possibilities where our universe might be but one note in a grand cosmic chord, whether through infinite repetitions, endlessly bubbling new realities, branching quantum choices, or the fundamental existence of all mathematical structures. The multiverse concept invites a truly expansive imagination. It offers a gentle answer to why our universe seems so finely tuned for life, suggesting we simply find ourselves in one of the countless worlds where conditions align. This removes the burden of exceptionalism, replacing it with a sense of belonging to an unimaginably vast, diverse, and generous cosmos. It can be profoundly liberating to think that every path, every possibility, might exist somewhere, in some form, within this grand cosmic tapestry. We then felt the profound, invisible embrace of gravity, redefined not as a mere pulling force, but as the elegant curvature of space-time itself. This cosmic architect sculpts galaxies, bends the path of light, and holds us gently to our home planet. We marveled at gravitational waves, the faint ripples carrying news of colossal cosmic collisions, allowing us to hear the universe's most powerful events, even the extreme distortions of black holes. Those profound wells in space-time become objects of quiet contemplation, reminders of gravity's ultimate power and its role in recycling cosmic material. Gravity, in its omnipresent gentleness, connects everything to everything else, forming a seamless, elegant whole. It's a constant, reassuring presence, a cosmic hand holding everything in its place. And then we encountered the enigma of dark matter, the unseen scaffolding that accounts for the vast majority of the universe's mass. Its invisible presence explains why galaxies spin so fast without flying apart, why clusters of galaxies remain bound, and how the large-scale structure of the cosmos could have formed. Dark matter is a humbling mystery, reminding us that most of reality lies beyond our direct perception, acting silently, profoundly from the shadows. It whispers that the visible world is but a small part of a much grander, hidden architecture, inviting us to appreciate the unseen foundations that support all that we cherish. This acknowledgement of the unknown can bring a quiet sense of awe, reinforcing that the universe is far richer than our immediate senses can discern. Diving into the microscopic, we explored the bewildering yet captivating whispers of the quantum realm wave-particle duality, where tiny entities express both particle and wave natures, superposition, where possibilities gently coexist until observed, and entanglement, that spooky action at a distance, linking particles across vast cosmic gulfs. The quantum world teaches us that reality is fundamentally probabilistic, fluid, and interconnected. It suggests that our very interaction plays a role in defining the world around us, blurring the lines between observer and observed. This inherent uncertainty is not a flaw, but a profound beauty, inviting us to let go of rigid expectations and embrace the unfolding, vibrant mystery of existence at its deepest level. It reminds us that even the seemingly solid world is built upon a foundation of shimmering potential. Our journey also led us to contemplate life in the cosmos, from the familiar comfort of our planet's habitable zone to the intriguing possibility of subsurface oceans on icy moons and the theoretical wandering of rogue planets. The explosion of exoplanet discoveries fills us with hope, suggesting countless worlds where life might have taken root, waiting to be found through the faint chemical whispers of biosignatures. The Fermi paradox, that gentle cosmic puzzle, invites us to consider the myriad ways life might emerge, evolve, or simply choose to remain silent across the universe's vastness. It reminds us of our unique, precious existence, whether we are rare or common, a living testament to the universe's miraculous capacity for complexity and self-awareness. It offers a profound sense of gratitude for the gift of consciousness itself. And finally, we cast our gaze into the unimaginable future, contemplating the ultimate fates of the universe, the Big Crunch, the Big Freeze or Heat Death, and the dramatic Big Rip. These vast cosmic timescales, from the silent death of stars to the slow evaporation of black holes, offer a profound sense of impermanence. Yet, this contemplation is not meant to be daunting. Instead, it places our precious present moment into a grander perspective. If all things, even the universe, are destined to change and eventually transform, then every breath, every quiet thought, every moment of peace you find now becomes infinitely valuable. The whispers of a cyclical universe, where new beginnings emerge from cosmic endings, can offer a continuous sense of renewal, a gentle reassurance that existence itself is an unending dance. Throughout this journey, we have not sought definitive answers to these grand cosmic questions. Indeed, many of them remain at the frontiers of human understanding, beautiful mysteries that continue to inspire generations of curious minds. And that is precisely the point. The beauty lies not in the rigid certainty of knowing everything, but in the gentle, boundless act of asking, of wondering, of reaching out with our minds to touch the edges of the unknown. This quiet exploration of scientific concepts, presented not as lessons but as lullabies, is an invitation to let your mind wander freely, unburdened by the need for quick solutions or conclusive statements. It is a space where you can connect with the universe in a deeper, more personal way, finding solace in its vastness, comfort in its mysteries, and peace in its intricate, unfolding beauty. Allow the gentle echoes of these cosmic ideas to settle around you now, like a soft, comforting blanket. You are connected to the Big Bang. You are moving with time. You are made of stardust, and you are part of an unimaginably vast and wondrous reality. There is nothing to fear in the unknown, only boundless possibility and profound peace. Let go of any lingering thoughts. Release any tension you might be holding. Simply breathe and allow yourself to drift. The universe continues its grand, silent dance, and you are cradled within it, safe and secure. Embrace the quietude. Embrace the wonder. This is not medical advice and is not a substitute for any treatment. The purpose of this content is for relaxation and reflection only. Rest in peace, now wishing you a deep and restful sleep.